I'm going to get a same mic. Okay. We are going to be hearing next from Dr. Monique Udell. She is an assistant professor of animal sciences at Oregon State University. Her work focuses on the development of cross-species interactions and bonds, including those between humans and domestic dogs. She has spent years working closely with working dogs, pets, and strays, as well as human socialized wolves, coyotes, and foxes, investigating lifetime and evolutionary factors that contribute to the social behavior and physical problem-solving abilities of canines. She co-founded the Canine Cognition and Behavior Lab at the University of Florida, and in her spare time she can be found exploring the diverse terrain of Oregon with her husband and border collie. Please join me in welcoming Monique Udell.
Thank you guys for being here. I know I'm coming towards the end of a wonderful but long 3 days, so thank you for sticking with me. And being last has some of the advantages of getting to touch back on what some of the others have talked about, so I will do a little bit of review of certain topics, but hopefully expand on them and integrate them in some interesting ways as well. But I'm going to start by making you do some work. I want you to take a look at these pictures and put yourself in the situation where you're addressing this behavior with a client and think about what you might say. So what's the first response you might have? Where does this behavior come from? What advice might you give that client? So take a second to think about it. You can write it down or just hold it in your head, and we'll come back to this a couple of times throughout the talk. So hopefully you've got something. Now what you put down or what you thought about likely has to do something with the perspective that you take in your field. So it may have to do with the school of thought, or maybe if you have a degree in a particular area or field of study, or maybe who you've apprenticed with. And the interesting thing is you may all be right. So there are actually multiple perspectives from which you could address this behavior, and even though you might use different terminology or you might have slightly different explanations, it's possible in some cases for more than one explanation to address the same behavior, even though nothing actually changes in that situation. And in fact, it was Tinbergen, who is a very famous Nobel Prize-winning biologist or ethologist, who suggested to truly have an integrative understanding of behavior, we have to ask 4 different questions. We have to know, how did the behavior develop? What was the physiological cause? How did the behavior evolve? And also, what is the behavior's function? And we've heard about this several times throughout the last few days. But what this means on a practical level is that some scientists could say, for example, that the human-canine bond is dependent on oxytocin, so oxytocin's effect on the dog's brain. And another scientist could say, well, actually, human-dog bond is dependent on early socialization, on interactions that occur early in the dog's life. And they both could be right, and in fact, both are right. But integration is challenging, even when we know that it's potentially useful. And we've been hearing all throughout the talks about some of the challenges that you face with integration, even as scientists who believe in integration or as practitioners who want to integrate these different fields. And the fact that you're all here listening to these diverse talks probably means that you are at least interested in the possibility of integrating across different fields, if not already actively integrating these things in your practice. But even if you don't particularly find integration challenging, many people do. And so it's a concept that many clients have difficulty with, many of the general population have trouble integrating, and even many scientists find this kind of challenging. And so there's some questions that we can ask and some things that we can address to try to understand why this is, and also what we can do about it. So some of the things that stand out to me, just in my experience of dog training and also research, is the questions that we get asked are things like, why is there so much disagreement, especially among scientists? Why can't we seem to agree? Is one school of thought or one area or perspective inherently better than another? How do we know which ideas are right? And then importantly, how can we apply this knowledge, especially when there's so much of it? And this is all going to be central to how we can potentially integrate this knowledge, how we can understand it as a unit, as opposed to just different perspectives that we can't necessarily put together. And so I'm going to address actually more about human behavior in many cases today than specifically about animal behavior, although we'll have animal examples throughout. But I really want to touch on some key concepts that I think help us understand some barriers to integration, and then maybe also some potential solutions that allow us to overcome some of these hurdles. That's perspective, prejudice, understanding the scientific process, which includes predictions and also parsimony, and then we'll address practicality in terms of how do we apply this knowledge. All right, so back to Tinbergen. So I said that there are 4 questions that we're supposed to answer to do an integrative perspective of a behavior. And some of you might say, well, 4 doesn't seem so bad. It's a bit of work to learn 4 different sets of terminology and 4 fields and 4 ways of thinking about things. And as many of the speakers have mentioned, often these 4 areas have different rules for how we even approach the study of behavior. 4 is not so bad. But the reality is a bit more complicated because each of these 4 areas has now been broken up into many, many distinct fields. So these are just a few examples. But you can see already, now we're moving from 4 questions that we have to ask to many perspectives, many different terminologies, many ways of thinking, and this can be overwhelming. And so probably the most complicated or potentially the most confusing thing that people encounter first when they go to read a textbook in another field or study another area is the terminology issue. And that's something that's been brought up multiple times today, that these different fields do have different terminologies, and sometimes we have different words for the same thing. So some of the disagreement that we hear between individuals, whether it be science or in practice, is actually just miscommunication. So 2 individuals may be in complete agreement, or maybe they don't even realize that they're in agreement, but they may be describing a very similar phenomenon, but using different words that seem to be in conflict. But there's another side to this as well, is if we take an integrative approach, not only can we maybe understand the parallels between some of these words, but in some cases, like Patricia said earlier today, the words themselves are important. And sometimes the way different scientists from different fields term things or talk about things can actually give us a little bit of extra insight that we may have missed from those other perspectives. And by understanding the terms from these different areas and the different ways that they're talked about, we can actually put together a bigger picture that might give us a little bit more information than we would have had from any one perspective alone. So I want to talk a little bit about that with our first example. What is going on here with this dog? And I will say up front, these are just examples. So in the real world, you would definitely want to investigate the situation, and there may be more than one explanation for this behavior, even across all of these different perspectives. But this is just one way we could potentially integrate this information. So we'll start with cognitive psychology, or neurology. And we've already heard a bit about how some of these compulsive behaviors look a bit like what we see in humans, obsessive compulsive disorder. And we can learn, if we look at that human literature and we want to take from that a bit, that oftentimes the compulsive behavior, so the repetitive behavior that an individual engages in, is not directly related to the thing that's causing the anxiety. So for example, someone might be compulsively neat or need to trim their grass excessively, and they may not actually be anxious about the height of their grass. They might actually be anxious about something like a financial troubles, how much money is in their bank account. Someone might excessively wash their hands or count their steps, not because they're worried about germs in every case, and not because they're worried about how far they've walked, but they might be worried about the health of a family member. So some insight that we can gain from human psychology in this respect is that we might not just be looking at a dog that feels the need to be excessively clean. Maybe there's not necessarily a skin disorder. The anxiety might actually be stemming from something that could appear totally unrelated, but could still be causing the anxiety that causes the compulsion. So for that, we might want to look to ethology. And we might want to look in situations in which animals engage in compulsive behavior, usually in a situation of anxiety. And an example or a term for this in ethology is displacement behavior. So oftentimes this occurs when an animal is in a situation where it would normally complete a particular motor pattern or would be trying to obtain a particular resource, and it's unable to do so. So that resource is unavailable or it's prevented from completing that particular action. And then sometimes what you get is behavior that is, it seems inappropriate or out of context for the situation, but can be very ritualized or very compulsive. And so an example of this in a non-dog species is with betta fish. If any of you have had male betta fish before, you know it's not especially a nice thing to do to put them next to another male betta fish because their tendency is to want to have competition And so they have this very elaborate sequence of behaviors that they go through when presented with another male betta fish. It involves things like swimming back and forth to size each other up, puffing gills, fanning out their fins. But because they can't get to each other if they're in different containers, what you often see happen is one of the male betta fish will blow a bubble nest. This is also a very functional behavior. This is what males do when they want to mate. They blow a bubble nest, and hopefully a female will come along and put eggs in that nest, and then they can fertilize them. However, it sort of seems out of context in this particular scenario. They're blowing a bubble nest in the in the presence of a potential competitor. And so what we can see here is that this other behavior that the individual that's engaging in is maybe not just completely random. It may have a context within ethology or within biology. However, it may not be exactly related to the anxiety-inducing stimulus. So instead of looking at a behavior like the dog licking the paw and saying, oh, well, maybe they're anxious about something else, maybe it's that new cat we brought home, or maybe they're mad or spiteful at us, we could say, well, what are the relevant behavioral contexts that we can look at in their environment that they might be deprived of? So are they not getting enough exercise? Do they not have access to food? Do they not have access to water? We can look at more biologically relevant stimuli and see if there's a connection or pattern there. So how do we identify what stimulus might be important? How do we identify which biological stimulus could be the key? And to that, we might actually turn to learning theory. And so in learning theory, there's a term called adjunctive behavior, and it actually is really helpful in these sorts of scenarios. And I'll just give you an example to explain what this means. But for example, let's say this is your average dog's activity for the day. The dog, you leave and the dog goes to sleep and takes a nice long nap. And then you come home around 5 o'clock in the evening, you walk in, your dog greets you. It's woken up recently, so it starts grooming itself. And while it's grooming itself, you've just gotten home, so you're in the kitchen preparing its food. And 5 minutes later, you plop down that food. The dog eats, all is well, and then it goes about its normal routine after that. However, let's say in a couple of months, your schedule changes, and now you get home at 3 o'clock. So your dog sleeps, you come home at 3 o'clock, your dog greets you, it starts licking itself, but now you don't prepare its food until 5, like you always have, because you're trying to remain consistent. But now the dog may actually engage in that grooming behavior for 2 hours instead of 5 minutes, because it's developed a behavioral chain. And so this is just what the dog does. It grooms until it gets its food, and once it gets its food, then it can stop the chain and resume. And one additional problematic thing that can sometimes develop is that the dog may make such a strong association between grooming and receiving food, even though it's not intentional on your part, that the dog may actually start to groom whenever it's hungry. And so this is adjunctive behavior when there's this unintentional chain that's potentially set up, and it essentially reinforces an undesirable behavior that's natural in the dog's day-to-day life, but isn't actually causing the presentation of food. So for this last one, you might say, okay, well, how am I going to describe this as an adaptive behavior? How can this be evolutionarily advantageous? But if you think about it from a behavioral ecology perspective, if you're hungry and you don't have food, probably the best thing to do is the thing that you usually do before you get food, and to do it until you actually get to eat. And so these are natural biological patterns, whether they're motor patterns or scavengers may be scavenging, but that is going to be effective in a naturalistic context. But when you take the dog out of context and you're providing its food, then the thing that came before receiving the food may or may not be necessary to obtaining it. And so you might actually get these compulsive behaviors developing that are tapping into this naturally adaptive thing out in the wild that doesn't make a lot of sense in the home. And so I would argue that there are many different ways that you could potentially explain this behavior, and certainly there are things you can do to sort of get at the root of these behaviors, but each of these different terminologies and ways of thinking about this problem actually contribute something unique and important. And so in some cases, I believe that integration can actually be really advantageous to helping us not only understand the causes of behavior, but think of unique solutions when we're actually trying to find applications for utilizing these different techniques in our day-to-day lives or in training or in practice. So another advantage of being last is being able to point back to specific examples that previous people have given. And I think there are some other examples here that are sort of relevant and how these different fields can actually draw together explanations that are valid simultaneously. And so several times we've talked about the herding behavior, herding dogs, and the motor patterns that they engage in. And there was some debate about, is this biologically ingrained or is this learned? And so I have a border collie, and I can guarantee you, if I put her out in a field with sheep, she will eye, she will stalk, she will chase. She may even engage in behavior that looks a bit like herding. She's never seen a sheep before. So I totally believe that. However, what I can also assure you is that she would not herd those sheep towards me. She would not do anything I was telling her to do in terms of direction. She would probably run straight at the sheep. They would scatter. It would be a disaster. So when we see things like this, we have those motor patterns that are really critical to these dogs being successful, but we can also manipulate those motor patterns through operant conditioning in many cases. And so the end resulting behavior is a behavior that's part biological, part motor pattern, and part reinforced through potentially operant conditioning or training to get a final product that is different than you would get if either of those pieces were missing. Now, this isn't just for dogs, this is for people too. And one of the exciting things that's going on right now is research in biofeedback. And basically, you can hook yourself up to a machine and actually see your heart rate and your breathing rate in real time. And multiple people have brought up breathing rate as well. So you breathe, but you don't necessarily think about it. But now that I've mentioned it and others have mentioned it, you're probably thinking about it now. And you can control your breath. And so basically that's what this technology does. It allows you to be aware of the breath that you're taking and control things not only like your breath, but your heart rate and your blood pressure as a byproduct. That's also the point of things like meditation. Now there are also games that have been created to maximize on this because people find watching their heart rate boring after a while. So there are excellent games like this dual drive game, which if you haven't seen it, it's really fun to watch the demos. And basically the idea is you have this race car, and in order to win, your car has to go faster than everyone else's, just like in any racing game. But the difference is what's controlling the speed of your car is your heart rate. So if you have a smooth heart rate, which means you're relaxed and you're breathing easy, then your car goes fast and this loud music plays and it's very exciting. And if you get angry or tense, your heart rate gets irregular and your car slows down and fog drops over you. Which you can imagine is very stressful. So you have to not only control your heart rate and your breathing, but you also have to do it under situations that are potentially more and more stressful. And they should really implement this in real cars because it would significantly help road rage, I think, if every time someone got mad, their car just stopped. I'll just go right by. Okay, so integration is great, right? There are examples of how integration is good. But human social nature, I think, maybe sometimes pushes us more towards specialization. And there are advantages to this, and there are real reasons for this. One is that it allows you to know a lot about some things. So there's a lot of information out there. You probably can't know everything, so maybe it's better to know a lot about a couple of things. And that allows us to specialize and really be able to provide advice in a particular area. Also, specialization provides a framework for interpretation. Like we said before, there are rules to these different fields. It's not just the terminology, but there are also ways about answering and asking questions that sometimes provide us with the ability to make decisions quickly without having to think through it explicitly every time. And probably the most important is that specializing provides you with a community of support. So if you think about what group you feel most affiliated with in terms of dog training, you go to their conferences, you interact with those people. If you post on a board some solution to a problem, they all probably compliment you. That's very reinforcing. But it also makes you feel more confident in what you're doing. And so there's a real psychological advantage there. But the problem is there are people in all these different fields who feel exactly the same way about their sub-area. So that can be challenging. So what I want to do quickly is focus on team behavior, because that's an important thing when we're talking about aligning with any one perspective or any one group. So it's going to give you these instructions again, but just in case I don't know what the audio is going to be like, so I'll say, what you want to do is you want to watch the white team, you want to watch how they interact, and count the number of times they pass the ball.
How many passes does the team in white make?
Go!
The answer is 13.
How many got it right? Okay.
But did you see the moonwalking bear?
Okay, so one disadvantage here, right, of focusing on one team or one perspective is that in some cases you risk making blind mistakes. So if you're only looking in one area for your solutions, you may not even notice when your particular perspective is lacking an answer to something that might be found somewhere else. And so one of my favorite examples of this actually comes from an article of Misbehavior of Organisms. I really love that article. I use it for my class. But one of the things that is interesting about that article, and I'll talk more about it in a second, is it demonstrates how focusing on one specific area can sometimes lead to blind spots that you can fill in with the knowledge from other perspectives. And sometimes that's what's necessary for integration. So in this particular paper, what they were describing actually was a series of training mishaps. So training exercises that went, in their perspective, wrong. And so two of the examples of things that potentially went wrong were a dancing chicken, which originally all they wanted this chicken to do was go and sit on a record and just stay there, and it would play music out of a jukebox. And they wanted a raccoon named Rocky to pick up 2 coins one at a time and deposit them into a piggy bank. Seemed simple enough. And initially, training was going pretty well. So the way that they describe it is initially, they were shaping through successive approximation. The animals were getting closer and closer to that final behavior. They were rewarding with food. And then all of a sudden, the behavior just started to fall apart. And what they ended up with in the end was a chicken that wanted to scratch on the record instead of just hold still, which could potentially be problematic with a record, but they made the best of it. And a raccoon that wanted to pick up the 2 coins, dip them into the bank, pick them back out, and wash. And this was a problem because initially they were training this behavior for a commercial on TV about saving money, and the raccoon kept pulling the money back out of the bank, so that doesn't set the best example. But really, if you look at these behaviors more specifically, what are they? And chickens often scratch when they are trying to obtain food, so this is a very natural behavior. And raccoons also engage in this washing behavior when they are presented with food. So oftentimes they find food in streams like shellfish, and they'll actually rub and break and wash the food. But they'll also do this. You can see videos on YouTube of people who probably shouldn't be feeding the raccoons, but are. And they'll take the cat food and do the same thing. They'll take it over to the water bowl, dip it, and rub it. So this is a very reflexive sort of response in the presentation of food. So this is incredibly frustrating, as you can imagine. But they try to make the best of it. So they coined this term, instinctive drift. And the idea was that they had discovered a phenomenon, or at least they were describing a phenomenon, where operant conditioning seemed to be breaking down. And instead, over time, the behavior of these wild species, or maybe not always wild, but the behavior of these animals were drifting back towards that instinctual behavior. And this was a really interesting time because there was a lot of presumably there was a lot of conflict at that time between this idea of you can train everything through operant conditioning, but then there was this ethological perspective that said, no, it's going to be more related to natural behaviors. And they actually said, well, we're actually seeing some interference of the natural behaviors in training. And so this was a really important paper, and I think still is. However, if we're really going to integrate our knowledge, I think we have to take this a step further and ask an important question. Why does instinctive drift occur? What is instinctive drift at a deeper level? And so to do that, we not only have to look at what's going on with the operant conditioning and what's going on with the biological predispositions, but we can also look at classical or Pavlovian conditioning, which you've heard a little bit about already. But I am going to give you just a quick recap, especially for those of you that might just be joining us. And basically, classical conditioning goes a bit like this. You have an unconditioned stimulus, so for example, food, and that elicits an unconditioned response. So for example, with the dog, that might be drooling. And this could be described as eliciting behavior, it could be described as a reflex, it could be described as instinct, which I have in quotes because as people mentioned, this is one of those terms that has come in and out of favor. But whatever you call it, it just happens. It doesn't require a conditioning process. If you present a neutral stimulus, like a metronome or a bell, as Clive mentioned, what you get typically is no response at first. However, if you present a neutral stimulus, you follow it by the unconditioned stimulus that results in the drooling, and then you do it again, right? After a while, you get something like this. That conditioned stimulus elicits now that behavior that was initially only provoked by that unconditioned stimulus. So because of the association and the pairing between that metronome and the food, we're now getting the response in the presence of the metronome that was originally only elicited in the presence of that food item. So let's quickly revisit what was happening with Rocky the raccoon. So the behavior that they meant to train was Rocky the raccoon was supposed to pick up one coin, drop it in the piggy bank, go back and pick up a second coin, drop it in the piggy bank, and each step along the way was reinforced with food. And like I said, initially that seemed to be working okay. Now food is an unconditioned stimulus, even if it's something other than steak, and raccoons, as we've talked about, respond reflexively in the presence of that unconditioned stimulus of food by rubbing and dipping. Now the coins in the piggy bank are initially neutral, so they have no real response to the coins in the piggy bank. So initially, having those props there in the context of operant conditioning is no big problem. They don't have any conflicting response to those stimuli. However, during training, we're reinforcing the behavior of interacting with the coins in the piggy bank with food. And so what we have all of a sudden is the presentations of a coin in a piggy bank followed by food, which leads to dipping and washing. And then it might happen again in the next operant trial. And even though we think we're only engaging in operant conditioning, actually what's going on is we also have an underlying classical conditioning scenario developing. And so ultimately what we see is something that was initially neutral stimulus is also now eliciting the response of dipping and washing, which is a classically conditioned behavior. So not only were we operantly conditioning the behavior intentionally, and not only was there a biological response, but unintentionally we had set up a scenario, or they had set up a scenario, where classical conditioning was also getting involved. And really the instinctive drift can be explained best by integrating all three. So when we integrate, sometimes what we find is that we can actually get an explanation that's more complete, again, than each of its parts. And so this can be really helpful in understanding that it's not just learning and it's not just instinct. It can actually be a combination of things that are going on, sometimes more than two things, sometimes three things, that may be resulting in the behavior that seems unexpected but can actually be explained when broken down a bit further. So in case you don't believe me, I'm going to show you a couple more examples. This is a video. I love this example because if you're not familiar with this, there's a professor, Alliston Reed, at Wofford College. Some of you might know him as one of the authors on the Chaser Papers. But he also does this excellent animal learning class where he has his students condition rats to play basketball. And at the end of the term, they have this big tournament where their rats compete in these basketball challenges. But why I'm actually showing you this is because it shows a good example of something you could call instinctive drift, and I'm also going to tie in another term, which is sort of another parallel term, called sign tracking. So go ahead and watch what the rat does. Now the rat is reinforced when the ball goes through the hoop. Food comes out the side of the container. That's the only thing it's reinforced for. But watch what develops. So the rats begin to chew on the ball, even though that's never been reinforced. And this doesn't, oops, I jumped ahead, sorry, I wanted to play it again. It doesn't happen right away. It happens after they've been reinforced a few times for putting the ball through the hoop, and it can actually develop into these long sequences where they're actually getting less reinforcement during a match because they spend so much time chewing the ball, which doesn't really get them anywhere, but they don't want to let go. They don't want to put it in. And so that's a perfect example of the same sorts of things, this feeding behavior now being directed towards this originally neutral stimulus. So I love Simon's example that he brought up of the coyote, and I'm not saying this is what's going on because I wasn't there either, and I don't know if this is the right explanation. But the example of the fact that when we feed wild animals that they lose their fear of us or they want to be around us is definitely correct. But something else might even be going on that we can look at maybe at a deeper level, and that is sign tracking. And so the idea of sign tracking is very much the same as instinctive drift. This idea that sometimes animals begin to engage in behavior that's maybe food related towards the stimulus that predicts the food as well. So this is how they get pigeons to peck buttons in operant chambers. All they have to do is light up the button and then follow that with food. Light up the button, follow that with food. And what the pigeons begin to do is peck at the light because that's natural food getting behavior for the pigeon. And they've associated this button with the presentation of food. So it could be that when we're feeding wild animals, we're not only saying, hey, come hang around us, but over time, we might even be conditioning them to engage in food-related behaviors around us, which might not be great if that food-getting behavior is something that's potentially dangerous for us. And this might also go back to Ray's example of why do animals or dogs especially seem to guard area where food was and not just the food item. Well, if you pair a location with a food item in the past, and sometimes they can learn this as quick as one trial, like that great turkey example, dropping the turkey, they may actually come to display the behavior that they would normally display in the presence of the food in the location where the food was before. In other words, in the location that predicted food in the past. And so these might actually be related principles, and you can't say for sure without examining those specific examples, but we know that this is a phenomenon that happens, and that it's one way that we can integrate these things that we're seeing across learning theory and ethology. So there are other cons of specialization that I think are important to address before we can really get to the full integrative practice that we'd hopefully like to get to at some point. And these are also unintentional biases and also resistance to different ideas, which we can contextualize as prejudice. So you might say, what is prejudice and how does that relate to dog training? Because we're not used to thinking about it in this context. But the definition of prejudice is any preconceived opinion that is not based on reason or actual experience. And we can even alter that further to say any preconceived notion that's not based on science or actual experience. And we all have those. We all are prejudiced about something, that we have these opinions or emotions about something, but we don't necessarily have the evidence or can't really explain those feelings thoroughly. And so prejudice leads to a couple of things. It leads to the pressure to conform to the beliefs of our community, which we've suggested already. Being part of a community is a very valuable, potentially reinforcing thing. And it also sometimes encourages us to follow the rules of a community, even if those rules we know are wrong, and even sometimes if those rules lead to harm. So here are some examples from human psychology. So in one experiment, the Ash experiment, participants were presented with a standard line, which you see there, and 3 comparison lines. And so what the participant was asked to do is they were asked to identify which of these 3 lines is most similar to the standard line. How many of you think the answer is 3? I can't see very well. Okay, good, because the answer isn't 3. The answer is 2. But in the actual experiment, what happened was they had 7 Confederates, meaning 7 people who were in on the game, and 1 real participant. And so when they asked the participants to answer this question, they had each of the Confederates go around the table and answer, the answer is 3, the answer is 3, the answer is 3, all the way until they got to the participant. If you've seen the videos of this, I wish I'd put one in. The person who's actually naive to this experiment's face is like, what is going on here? I'm pretty sure the answer is 2. But when it comes time to answer the question themselves, 37% of the people will agree with the rest of the group. They'll say that the answer is 3, even though they know that that's the wrong answer. So that's an example of this peer pressure to conform, even if we're not especially invested in the group of people we're with, and even if it's not that important that we agree with them at that time. So you might say to yourself, 37% of people, that is less than half, and this is also not something that could potentially cause harm. So what about more serious situations? Well, another famous example is Milgram's study, which actually suggests that 65% of people will deliver a fatal 450-volt shock to someone else if they're instructed to by an authority figure. And this authority figure is simply somebody in a lab coat, so not somebody that they know. And this was replicated by the BBC, which is not a scientific entity, but still interesting. In 2009, psychologists aren't allowed to do this experiment anymore because they felt it was too psychologically damaging to the people who initiated that shock, even though no one actually got hurt. So the person that sounded like they were being shocked was an actor. But they thought it was too psychologically damaging for people to know that they were capable of that. But the BBC can do what they want. So in 2009, they replicated it. And they found that it was the same thing. Around 65% of people, again, would go all the way up to the 450-volt shock. So that's an example of how conformity can potentially lead to harm. And many of these were very well-educated people. In the BBC, they actually tell you what their professions were. I think one of them was a nurse. So these are people who should know sort of what's going on, and it doesn't seem to matter. And in fact, there's other examples as well. So there's an effect called the bystander effect, and this is one example that's sort of been debated, but this is the one you see in a lot of textbooks. And it's this idea that in 1964, there's this woman named Kitty Genovese who was murdered on the streets of New York City, stabbed brutally for over 35 minutes, and reportedly up to 37 people witnessed this happening, and no one called the police. Now, this has been debated. The facts of this have been debated. Some people say it wasn't really 37 people, it was only 12. Others have said, well, you know, people thought something else was going on. But the fact of the matter is there are robust examples of this in other contexts as well. This isn't the only example. And in fact, people tend not to help an individual if others are around them in that context unless they're singled out. And they're even less likely to help if they don't feel like they associate with that person, if that person is in some sort of out-group. So they're dressed differently than them. They're from a different culture. They'll stand back, they'll see it happening, and they'll walk right on by. So we're capable of some situations of conformity that can potentially cause pretty drastic harm. So what about dog training? What are examples of conformity and prejudice in dog training? This is where I might get myself into trouble. There are a lot of ways I can go with this. You can think about just about any taboo or controversial word, and several of those have been brought up throughout the course of this conference. And every time one of us says that, this is potentially controversial or worried about talking about it, that might be an example of prejudice. Because if we're coming from a place of scientific experience and hopefully from a place of evidence, we should be willing to hear those explanations. We should at least be willing to learn about them. And I think that fear is caused by backlash from others that may or may not be well-grounded in reason. And so you can see I actually have note cards up here, and I haven't used them at all. This is the only section for which I'm going to use note cards because I want to make sure I am precise in what I say in this particular case. And the reason why is because I'm going to focus on an area of bias that I believe has arisen out of the best of intentions. And because this topic is so taboo, I am going to try to be very careful and clear, but I'm sure that there are going to be people who still disagree with me, and I hope minimally you can hear me out and hear what I am trying to say, what the message is. So we've come a long way in dog training, and now can do amazing things with dogs using positive reinforcement alone, and I think that is great. This method scientifically has the lowest chance of negative side effects, I believe that fully, and it can improve the human-animal bond and make training a lot more enjoyable for both the owner and the animals involved. However, the blind dedication to even positive reinforcement training can lead to the same kinds of bias and potential for harm that we've been talking about in these other examples. I've known excellent dog trainers, excellent animal trainers, who have actively included and then at the last minute omitted information about punishment or other forms of aversive control in talks about behavior modification, not because they had a change of heart, but because they were afraid of upsetting the audience. And I've already admitted to you that I'm nervous about this, and I will admit to you that I almost became one of those speakers. The truth is that we should never have to be afraid of presenting information based on science, reason, and experience, including information about punishment and aversive control, whether or not we agree with its use. And the reason why I think it's dangerous for us to agree to not talk about it, maybe even more dangerous than to take that risk, is because aversive control is real. It's a natural contingency. It can work. It often works fast, and sometimes even faster than positive reinforcement. And that is incredibly reinforcing to the person implementing it. As professionals, we know that there are real side effects to punishment and negative reinforcement, and there are also right and wrong ways to use it, if it's going to be used at all. And there are decades of science on the subject to back it up. However, our failure to talk openly and honestly about scientifically demonstrated pros and cons of negative reinforcement, punishment, or any other form of aversive control, often for fear of prejudice, prevents us from making the strongest scientifically based argument for the use of positive methods, even when positive methods may be the best option. It also prevents us from providing scientifically sound information about when and how punishment and negative reinforcement may be an effective option, and how it can be used effectively while minimizing harm or negative side effects. And anyone who's ever used a timeout with a dog, or even put a dog in extinction, has used aversive control. So that's really important to keep in mind. We need to be more clear as a community that not all forms of aversive control, like timeouts or even some forms of punishment, are cruel and harmful. The behavioral procedure and the chosen technique are two separate things, and this distinction can make all the difference to a dog's well-being. While some of us may know that, I think the broader public often doesn't. And if we are not willing to educate them, there are plenty of programs on TV that will, and there's a good chance that that information will not be scientifically sound. And I think that's becoming a bigger and bigger problem in our community. And when we fail to provide evidence-based information about both sides up front, frustrated owners may turn to aversive control to expedite results, or as a last resort, without any sound knowledge or professional guidance about techniques or the dangers of implementing aversive control incorrectly. And if that procedure works, they're going to use it again, because it's going to reinforce what they did, and it's going to reinforce their behavior. Therefore, I think our silence about aversive techniques may have greater potential for harm than the use of a squirt bottle, timeouts, or even a low-level shock, which I know I'm going to get in trouble for saying. We need to be honest about this, though. We need to be honest about what the alternatives are, why we choose what we do, and back up those opinions with scientific evidence and experience, not emotion. Because this only makes our promotion of positive methods more credible when we can and do champion them. And I think equally, we also need to be honest when our preferred methods or explanations may be insufficient, so that alternative options can be pursued. And this goes back to the idea where different ways of thinking can be right simultaneously. When we indiscriminately paint a negative view of aversive control, irrespective of context, we may fail to see that in some cases it may be the most humane choice, or may even save an animal's life. So when we base our ideas on community perception instead of science and experience, we risk the kind of prejudice and lack of flexibility that can lead to serious misinformation and harm, even when our intentions are good. And as scientists and canine professionals, we cannot escape the possibility of prejudice, but we owe it to our clients, their dogs, and ourselves to think about what biases we may have and how we can work to overcome them when our own perspectives fall short. Now, this is just one example of an area where I think that this might be true, but there are other areas as well. And in all areas, especially areas of taboo and controversy, I think we should try as a community to back up our claims, opinions, and suggestions with evidence and experience, so we leave little doubt that the guidance that we are offering as a community is as complete, scientifically sound, and as free from bias as humanly possible, independent of the issue or topic at hand. And to be clear, if I'm not clear, I'm not advocating for the increased use of more aversive control. What I'm advocating for are decisions based on science and experience, because there's just too much misinformation out there for us to be coy about this topic. Prejudice is a shortcut that we use when we don't understand something well and aren't willing to take the time to learn. And so I think this is something we need to be informed about as a community, just as are topics like dominance and consciousness. And so we're discussing those here, and I think that's a big step in the right direction. And I hope we can all be a part of that. All right, so now I'm moving past that part. I thank you for sticking with me, but I do think it's important, all joking aside. I think that being able to discuss these topics that are difficult is just as critical as discussing the topics that are fun and interesting. And so I felt it was important to leave that in there today. All right, so understanding the scientific process is another area that leads to challenges in integration. And so in some cases, disagreements between scientists are based on these terminology issues, or maybe they're saying the same thing in different ways. But there are also real disagreements among scientists about why things are the way that they are. So what do we do then? Well, it helps to understand the scientific process and understand why this is the case and why this isn't even a bad thing, how this is a natural part of the scientific process. So how does the scientific process work? Well, typically, a hypothesis is proposed by a scientist or a group of scientists. They typically test that hypothesis. And if the question is viewed as valuable or interesting, what happens is other scientists come along and say, that's an interesting thought. We should test that too. And it's called replication. So they can either replicate the exact procedures and see if they get the same results, and other scientists may take that general question and do variations on that test to see if the results hold up to scrutiny from different angles. And this is a very good thing. Science does not work without this process. And so through this process, these other scientists that are hopefully unbiased and external can determine whether the hypothesis is holding up to scrutiny, whether their findings seem to match the original predictions, or whether they're finding examples of that hypothesis being falsified, meaning that there are certain conditions under which the hypothesis is not true. And based on those findings, what typically happens is there's a conclusion drawn that the idea is robust, that many scientists from many angles have tried to poke holes in this idea, and they can't. And so we have a good indication that this might be true, although, as Prescott said, on the first day, or on the second day, actually, I believe, you never are necessarily proving something is 100% true and unchanging in science. What you're actually doing is you're trying to falsify, and if enough people test an idea and can't falsify it, can't prove it false, then we have a good sense that it explains behavior in a lot of cases. Or we poke at it, and maybe some pokes don't go through and others do, and so we have to revise the hypothesis a little bit. There's merit to it, but it doesn't hold true in every case. Or it doesn't really seem to hold up to replication and scrutiny in general, and it may have just been a fluke that it worked out that one time, or maybe there was some sort of error in the process. But in that case, the hypothesis may be completely replaced by other ideas, by other explanations for what's going on, and then the process repeats. Then we'll have to test those hypotheses. Now, I got this magazine a few days before I came here. I thought this is a great example, even though it's not about animals. But if you can't read the subheading, scientists labeled fat the enemy, why they were wrong. And the reason that we see so many headlines like this is because in an ideal world, we would go through that scientific process at least a few times, do at least a few replications before determining that something was likely true. We need some people to try to poke some holes into the idea from multiple angles first. But in the reality, what happens is as soon as a scientist completes a study, if it's interesting at all, it usually immediately gets sent out by the media in a million different directions, and it's usually purported as truth. And so as scientists, we have to be very careful to try to not over-exaggerate our results or the implications of our results. But as a community, I think we need to be aware that even if the scientist tries really hard not to over-exaggerate the results, the media will probably do it for them. So what you're reading sounds very much like you're hearing the truth, but it might just be the first step of that process, and there might be a lot of changes and a lot of evolution that need to be made first before we know for sure. And so what happens is it leads to this idea that science flips and flops back and forth and is maybe unreliable or not a very good process for answering these questions. And the real problem is not the science, but this urgency of getting this information out before it's really withstood the test of time. So this is one personal example that I can relate to, and I think something that sort of sticks in my mind, an example that sticks in my mind is, I remember when I first started to talk about point following experiments that we had done in our lab, And some of our results have contradicted what others have said. So just to give you a brief background, I know it was talked about before, but the idea is, do dogs follow points when you point to one container or another? Do they respond to human gestures? And it seems very simple, but it has implications for cognition, human-animal bond, for learning theory, all sorts of things. And so it has become a big debate over where this behavior has originated from. And so initially, when we had started presenting findings that seemed to contradict things that had been said in the past, we started finding evidence that learning might actually be important to these behaviors. We got a lot of backlash. And I remember one time giving a talk and getting feedback saying something of the regard of, other people have done this, why don't you find your own field to study in? Something along those lines. And I remember thinking to myself, I don't know that everyone understands that that is the natural process of science, that you're supposed to replicate these ideas, and it's very important. And so first of all, attempts to replicate or falsify an idea, a hypothesis in science, are not mean-spirited. We need to have a change of perspective. If anything, they're flattering, because it means that other scientists think the idea is interesting enough to pursue themselves. But if we actually look at the hypothesis initially proposed in this particular case, this is how we would go through that same scientific process. And the initial hypothesis, the initial prediction, was that domestication was leading to changes in the dog that resulted in point following. In other words, if an animal was domesticated, specifically if a dog was domesticated, it should follow points no matter what, independent of its life experience and age and so on. And that non-domesticated animals, especially wolves, should not be able to do the same, independent of their upbringing, experience, and so on. And not only from our lab, but many labs have actually found evidence to the contrary, that this is not always true. In fact, dogs do not always follow points. I mentioned the other day that dogs living in a shelter often struggle with this initially, unless you give them extra training and experience. Young puppies can struggle with this behavior. I found livestock guarding dogs do not follow points well, probably because there's a predatory component to the actual following of movement and approaching. And so they seem to have an inhibition for this behavior initially, but they can learn it with time. But I think the most telling thing is that if you look across studies, and I'm not the only one saying this, there was a great study by Marta Gassi that also showed this, that as many as half the individual pet dogs in any one of these given studies typically does not follow the point to the container. It's as an average, as a group average, they're performing above chance. But if you actually look at the number of dogs performing above chance, following that point reliably as an individual, more dogs can't do it than can. And so since we're typically working with individuals and not statistics, that's an important thing to know. And so I encourage you to all go home and replicate this with your dogs. It's a very simple experiment, and I would be willing to bet, am I doing that? I would be willing to bet that many of you find that your dogs do not follow the point. Now, they can come to follow the point with training and experience, and so this is a very important thing to recognize, is that with experience and with the right context, dogs can become very good at this. And so we have this idea that they're very sensitive to our gestures and our motions, and this is true in many, many cases, but they also can be flexible about this. They learn our unique gestures and motions, not just humans in general. And if you think about the 3/4 of the world population of dogs that aren't pets living in human homes, are they responsive to human gestures? That's a very difficult thing to test in this context. I would argue that they are, but I would also argue that if I point to a container, they're probably not going to run towards my hand. Most of them are probably going to run away. And there's good data from Ray's group that shows that dogs approached in Ethiopia by a human typically do run away. So it's not that they're not aware, but they may respond differently depending on learning and context. Do non-domesticated animals follow points? And this is another area. The initial prediction is the answer should be no. And there's been now study after study suggesting that especially human socialized animals can follow points even if they're not domesticated, including wolves, but also bats, elephants, jackdaws, seals, and the list goes on. There's a very extensive list now. So what this led to is the idea that the initial hypothesis, while it did have some very interesting components that maybe will hold up over time, the idea that domestication is the only thing that's necessary for responsiveness to human gestures, and that it even is necessary that non-domesticated species can't do it, was falsified, and it has been falsified falsified by many groups. And so one of our suggestions is that we propose the two-stage hypothesis, which didn't suggest that evolution and domestication were unimportant, but also suggested that socialization to humans and learning were necessary, probably along with other factors, including biology and evolution. But without these two things, you seem to get behavior that doesn't really represent this point-following scenario that has so frequently been described in the literature. So coming back to that Time magazine, I think one of the biggest challenges that many scientists encounter is that when an idea gets out there, it gets out into the public, or even out into the broader scientific community, and people come to accept it, and they talk about it, and they use it in their practice, they are very resistant to change that idea or change what they say, even when the evidence starts to move in another direction. In science, the scientific process is an evolution of ideas. It changes over time. And so one of the things that we can do to integrate new information is just recognize that new information is not a criticism of old information. It's just the evolution of that information. And the hypothesis we proposed, I hope more and more people test it and move it forward to something even closer to the truth. That's just part of the process, and I think it's really important to keep that in mind. Another important component of science is the principle of parsimony, and several others have mentioned this as well. And this is the idea that among competing hypotheses, those with the fewest assumptions should be selected. And this is a really important principle because the idea here is that we're not just chasing every whim of an idea that anybody proposes. What we really want is prediction and control. So ideas that have fewer assumptions means ideas that are more based in scientific principles that scientists have already demonstrated and hopefully understand to a greater degree. So putting together ideas that have some basis in science already to describe new phenomena. And the trouble with taking a non-parsimonious approach is that there's always going to be an infinite number of increasingly more complex explanations. So having a simple explanation doesn't mean that more complex explanations can't be true, but there's no possible way to disprove every complex explanation that you could ever come up with. And so this is why science operates from picking that simple explanation that you can really apply, and you can actually see the prediction and control happening in many cases. That's usually going to be your best bet. So here's an example, and I think it's interesting to note that these simple explanations or these parsimonious explanations are often deemed killjoy explanations, and you'll see why in just a second. But this is an example I show for my class, and I initially describe it the way it's described on the internet as an elephant painting its self-portrait. And once I convince everyone that this is really an elephant, because most people say, no, it's a person in a sweatshirt that just looks like a trunk. It's really an elephant. And I think it's pretty impressive. And usually people are oohing and ahhing at this time. You all don't seem too impressed, but. Thank you. I appreciate it. And so this is a cool behavior. This is a complex behavior. But then I explain that this behavior was actually operantly conditioned. It was trained by a trainer. Not only can this elephant do it, but if you look closely in just a second, you'll see that many other elephants in the park are also painting what appears to be their self-portrait. And they were trained this step by step. Now at this point, you guys, group participation again, everyone becomes really disappointed, right? Good. Excellent. If I had a clicker, I do have a clicker, but. So the question is why? Did the behavior change? Is the behavior less interesting? Is the behavior less complex? I would argue no. I think it's just as interesting. But the problem is now we understand it. We can predict it. We can control it. And although we want to know the answers to a lot of these questions, we want to know why our dogs look guilty, for example. We want to know why our dogs are doing the things that they're doing. And the owners want to know. Sometimes these simple explanations are just not as exciting as the things that we imagined. And so I think when we're really choosing between the magician and the plot spoiler, we often sort of root for the magician. We root for the explanations that maybe leave a little bit to our imagination and don't necessarily describe the behavior fully. But unfortunately, that may not be the best thing when we're actually trying to apply this information. because the less we understand, the more assumptions that we make, the more difficult it is to really address the underlying mechanisms that might be controlling the behavior. So people have mentioned the guilty look several times. Speakers have mentioned this, and I think this is a great example that we want to believe the dogs are guilty. We really want to, even though there are these more parsimonious explanations. We can look to ethology and say these look a lot like submissive behaviors. We can look to learning theory and say they're probably getting reinforced for this behavior, or minimally they're probably avoiding some sort of aversive control by engaging in this behavior when their owner comes home and looks a bit puffed up. That doesn't mean that these explanations prove that the dog is not guilty, but there's a good bet that those simpler explanations, if they're sufficient to explain the behavior, there's a good bet that those explanations are correct. And they're certainly going to be more useful when it comes to dealing with the animal's behavior in a training scenario. So the good news is that parsimony is just as useful in applied contexts, it's just as useful for trainers as it is for scientists. Because having to make fewer assumptions about a dog's behavior, what's going on, and sticking to the simple explanations that are visible and predictable has the best chance that you're going to be able to make an impact on the behavior in a way that's realistic and practical for the owner. So focusing on the environment, focusing on visible aspects of the behavior that you can actually see changing in real time is going to often be it's going to be the most practical and most sensible way to go. So how do we make use of this integrative knowledge now that we have all of these tips, or we see all these roadblocks? I have a few suggestions. The first is that we can recognize that more than one perspective may be valuable. We can be aware of our own blind spots and prejudices and work to overcome them. And like I said before, we all have them. It's just a matter of acknowledging it. We can also appreciate that science is a process and that knowledge evolves and it can take years to evolve. And so although we often want the answer right now and we want it to stay the answer for a long time, we have to be willing to sort of shift and change. And that's going to ensure that we have the best practices for the moment and aren't necessarily hanging on to something that science has already sort of moved away from a bit. So that's really important. And also to think critically about that knowledge when it is delivered to you. Think about how much it's been tested and what other factors might need to be tested before we're sure. And lastly, I think we also need to recognize that simple explanations don't necessarily mean simple behavior. We can get excited about behavior and recognize complexity in behavior that have simple explanations or explanations that don't require a lot of assumptions. We should recognize the value in parsimony and not just be excited about this mystery or the magic behind these behaviors. We should get excited about explanations that really help us understand. And lastly, I want to say that coming together at events like Sparks to discuss diverse ideas and perspectives, I think is a really important step in the right direction towards integration. So I really appreciate that you're all here, and I appreciate Prescott for having us all together for this event and the other speakers, because I feel like there's been a lot of integration this year, not only in the content of our talks, but even just between speakers. I feel like we've been utilizing the things that we've been talking about behind the scenes and with each other and up here on the stage to try to integrate our ideas in useful ways that we can move forward with really exciting new hypotheses and maybe explanations for behavior that we didn't have coming in. And I believe that the more that we expand these communities and seek out new knowledge, the faster we're going to move towards a robust understanding of canine behavior and also the human-canine bond. And I really want to thank all of you for being a part of that evolution that I think we're achieving. So thank you so much. Oh, I do actually, well, my mic's still on. I do want to also mention, I almost forgot, that in Behavioral Processes is going to be doing a special issue called New Directions in Canine Science, which is due out January of 2015. Many of the speakers here will have articles in that issue, often, or many of them will actually be about topics that you've heard at this conference. And the nice thing about this particular issue is that it's a promotional issue, so you'll have free access to those articles, which is something you can't always get. So write that down. I know it's a little ways out, but it'll be worth the wait and keep an eye out for that when it comes out if you want to learn more. All right, thank you.